Hello, programming languages students. Welcome back for another grammars video. Real quick, this will be a relatively quick video. I talked about context free in the last video, and if you looked at the bubble at the end there, so I'll flip back up a slide. We talk about context free and context sensitive. Both of these are drawable by, um, or creatable by grammar rules. And so we're going to talk about context sensitive as well. We will never actually in this class talk about recursively enumerable, but if you are interested, you can look it up on your own. We're going to really quickly talk about context-sensitive languages and definitions, and why they could be needed or useful. But all of what we're going to be doing in this class will be context-free. So this is just good information in general about these definitions that it can be useful to know. So I'm going to go relatively quickly through here. So context-free versus context-sensitive. Context-free means that production rules all only have one non-terminal on the left-hand side. So all the rules we've been writing are either capital S, capital A, capital B, whatever, and then we have our definitions. So these are all context-free rules. A not context-free rule would have more than that on the left side. And so the idea is that you have something that provides context. What is a surrounding character here? In order to create your rule, and that you actually need that context in order to be able to produce the language. So let's look at a context-sensitive language, one that you cannot create a grammar for with context-free rules. You cannot create a grammar for this language using only context-free rules. So a to the n, b to the n, c to the n. We're taking our a to the n, b to the n example to the next level, adding another terminal character, which also has a count. So why wouldn't this work? Let's think about writing a grammar for this. The grammar for a to the n, b to the n, we had s goes to a, capital S, lowercase b, or ab, right? So let's flip back up to our example here. Let's look at this rule. So a to the n, b to the n, we did this. If we were trying to do a to the n, b to the n, c to the n, well, we could add abc at the end here, and you could try adding a c here, but what's the problem? Well, if we loop back in, if we had ABC or A capital S B C or ABC, we go once, we get A capital S B C, and we try to replace that S again. If we replace it with ABC, what we get is A, A, B, C, B, C. So we would have the correct number, right? We'd have two A's, two B's, and two C's, but the order would not be correct. Um, And so, the trick we pulled here where we put S in the middle and just kind of insert more A, B's in the middle until it builds itself out, you can't quite do it that way with A to the N, B to the N, C to the N. And as it turns out, there's no way to write this without adding some context. And so what is the actual rule set? Well, this is the workable rule set. So we start with ABC, right? So this is our easiest case. Or we go to A. Well, A gives us a lowercase a, capital B, C, or ABC. And then this is where we start having context-sensitive rules. We have to have either lowercase cb, which turns into capital BC, or lowercase b, capital B, which turns into lowercase b. So these rules rely on context. What is next to our capital B symbol? If it's a C, then we're essentially going to shift our B symbol to the left. If it's a B, then we just add a B. So let's see what this actually looks like and how this works. So these context-sensitive rules I'm going to have on the right side here for reference. So we're going to follow our rules. We take capital S. If we wanted to write A, B, 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 C, 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 how do we do it? Well, we take capital S, convert to A. We take our capital A and substitute with our lowercase a, capital B, C. Right, so this is our word now. We then take this first A and replace it as well with lowercase a, capital B, C. So we get lowercase a, capital capital B, lowercase c. This was this A substitution, right? Capital A became A, lowercase a, capital B, C. And then we add our capital B, lowercase c at the end here. So we get a nice messy thing like this. Again, going left to right, we replace our final capital A symbol with ABC. So we choose the second option. And so we get A, lowercase b, lowercase c, capital B, lowercase c, capital B, lowercase c. So this is the problem we were talking about with our other language. If we just had lowercase b's here, we're out of order, right? We have A, B, C, B, C, B, C. So in order to get the order correct, or in order to, in other words, in order to reorder our variables here to get our b's in the middle, we need this production rule, which says based on context, if I have a C to my left and I am a capital B rule, I am going to shift myself to the left and move the C to the right. So with this capital B, actually, we'll start, I guess in this example, I'm starting from the right side here. We have a lowercase c capital B, and this will become a capital B lowercase c. So we basically we flip the order of the B and the C here. Then we do it again, shift the order. And we can then start making substitutions for lowercase b capital B to become lowercase b, and lowercase b capital B to become lowercase b. Um, and so basically these rules require context. If B is within a sea of C's, we move the B's over. Once we've reached our other B's, then we just start substituting B's back in, right? So the context of what's surrounding our capital B rule allows us to shift things around and ultimately get 3A's, 3B's, 3C's in the right order. So that's what context sensitive allows us to do, is it helps us to reorder things based on the context of what is around our rule.